A'udhu billahi minash shaitani rajim. Bismillahir rahmanir rahim. Assalamu alaikum. Uh, Here is the second lab of digital signal processing for given by Sir Dr. Jameel, and here is the task 1. As we can see that we will perform a step signal and we will assign three values in this task. First value is n0, second value is n1 and n2, -1, -3 and 3 respectively. So it will generate the step signal, and which will be our desired signal from these values. So this graph, this diagram shows the task 1 results, which is a step signal. So moving on toward the second task, which is also about the step signal, but we have changed the values, and we will get little changed results in this task. So when we run it, we get a value like this. So this is the only single line we have shown, but before that we were shown more than one line, and we can see that by changing only the values numbers, we see a huge change in the result of step signal. So moving on toward the third task, which is an exponential decaying signal. In this task we have assigned values and given commands, and at the end we have given a stem nx. So when we run this, we will get a decaying signal, which is a discrete signal. So as we can see that the value was at 25, below 25, and then in between 10, 15, and then 5, and then 4, 3, 2, and so on. This is showing a decaying curve. So moving on next to 3 task, part A. So in this we will see a sinusoid sequence of numbers, as we have given or we have assigned values n1 and n2 as -10 and 11. So we run this, and we get an output like this. There is some values, discrete values on x-axis, and the reflection are shown, which are in between them, not as reflected as they are, but in between these discrete values there are some values which are their reflection. It means that they are below x-axis. So now moving on toward lab task 4. So which we will, in this lab, in this task we will get a unit impulse through direct method. So we have assigned values, and axis location is -2, 2, -2 and 2. So now we run this, and basically we get a single discrete values, showing starting from x-axis and ending at y equal to 1. So now we will discuss a unit impulse. So this is function. We assign a function of unit impulse, and in this we can see that unit impulse values are 0, -5 and 5. So then when we run it, we get value like this. This is a straight line on this graph, starting from 0 to 1. So moving on to the next, which is unit step function, and function has assigned values, and now when we given value from the n is equal to -10 and 10, and axis its location is -11, 11, -1 and 2, and when we run this program we get a value like this, which is shown on your screen. Showing these results, we can know the value which has given lab task 5. So now moving on toward lab task 6. In this we will find values from function, as we have given them x1, x2, x3, and at the end there's sum. So when we run it, we get a result in a new window. So moving on towards the new window, so these are the results of lab task 6. So 0, 0, 1, 1, 1 and 0, 4. So now moving on to lab task 7. In this we will film our random variable, and we have assigned values x is equal to 0, 0, 0, 1, 1 and 1. There is an original signal and we see a flipped signal. So in the output of this task, so this is an original signal on the upper side, and below that there is a flipped signal. So moving on to the task 8, we are doing scaling in this task. First of all, the signal is 1 to 7, and scaling factors are also applied to it, and the original signal and scale signals. So these are two signals. One is shown as original signal and the other one is shown as scale signal. Since we have these two signals to be of same color, so we cannot differentiate between them. But if we have two different colors, we can differentiate between them easily. So moving on toward task 9, shifting of a signal. By shifting a signal, and shifting a signal means there is some original signal and we will shift that. So by shifting it, we can see that there are two signals are shown sinusoidally. So one of them is an original and the other one is shifted one. So moving on to task 10. So this is task 10, and we are representing continuous discrete in zero order whole. So we have given commands on MATLAB, and now run this, and we are shown a continuous signal and as well as a discrete time signal, which is a zero order hold. As we have as I have mentioned before, that we will represent continuous and discrete signal. So these are the results of them, and this was our task 10. Now moving on to the last task of this lab, which is the task 11, and we will get a first order hold. And first of all, I want to tell you that we will have an input signal in this and an output signal as well. So when we run this, we can see that there is an input signal on the upper side and an output signal on the lower side of this, as shown in the screen to you people. Thank you. This was lab 2, which is being done by myself. Thank you. Meet you soon in the next lab. Allah Hafiz. Take care. Oh.